Ladies and gentlemen, welcome to Chapter 4, Small Hydropower Plant Design, Deca Applications. The hydropower technologies of genetic, University of Science and Technology, Osaka. My name is Angelo Safis. This chapter focuses on the different layout of hydropower plants. The various civil works components involved, such as direction wires, salt basin, penstocks, and 4 beacons. The main objective is twofold. First, we will identify and describe the various components of small hydropower plants. And secondly, make assessment of the types of power plants, civil works components. General layout of hydro schemes. Various possibilities exist for the general layout of a hydropower scheme. The figure below shows some of these. You have a low head with a channel system. You have a low head with a river barrage or a small dam. You have high heads with no channel and high heads with a channel. Components of a micro hydro scheme. The various components of the water supply routes are 1. The diversion weir, a channel, an intake mouth, a 4-bay tank, regulating gates, channel crossing if necessary, spillways, a penstock, spillway, drains, penstock supports or anchoring systems, a salt basin, and a penstock anchors. This picture depicts some of the components of the hydro scheme. See the flat spillway structure, see the weir and the intake gates. You can also see the silting basin in the picture. For the design of hydro schemes, a number of essential factors must be considered as follows. 1. Flowing water in the river will always carry small particles of hard and abrasive matter. These matter may cause considerable damage to the turbine material and therefore need to be removed. 2. The river is always in a variable flow throughout the year, but the hydro installation is designed to take a constant flow. The main function of the intake structure will be to regulate the flow to within reasonable limits when the river is at its high flow. 3. High flow conditions are normal as in seasonal flooding and require particular attention from the designer. Floodwaters will carry suspended particles and will cause large boulders to go along the stream. This may damage the diversion weir, the intake structure, and the embankment walls. Careful must be taken in the design of the structures. Another factor demanding attention is the effect of turbulence in water flow. In parts of the water supply line, including the channel and the weir, sudden alterations to the flow direction will cause turbulence, which is erosive to structures, will induce energy loss and stir sediments in water flow. Since the power delivered by the turbine is strongly influenced by the head of the water at the point of entry to the turbine, it is clear, therefore, that the channel must not drop to height until the penstocks are sized so that friction losses will the head of the tube. If the water flowing in the penstock pipe is brought suddenly to a halt, for instance, by a sudden blockage at the turbine, then high pressures will result in the penstocks, and therefore the penstocks should be designed in such a way that these pressures will not cause any damage to the penstocks by ensuring firm designs of anchorings. Let's look at the system layout of a small hydropower scheme. Penstocks. The basic rule in designing any hydro scheme is to keep the penstocks as short as possible. A short penstocks will normally lead to the most economic scheme, but this is not always the case. Settling basin. You will require a certain basin to trap sediments or suspended silt on the water before entering into the penstocks. It may be built at the intake or at the forebay. Spillways. Spillways are channel flow regulators. In addition, they are combined with control gates to provide means of channel empty during certain emergency cases. The spillway must be large enough to remove excess flow. So for the spillway discharge, you have is equal to the flood flow minus the gross flood flow. Often, emergencies will occur when the river is in flood, that the gates will be required, for instance, to close or to allow excess water to flow into the spillway. Head raise systems. A head raise is a channel leading water to a forebay of the turbine. The head raise follows the contour of the lands on the hillside so as to preserve the emissions of the head tank. The head tank or a pump at the top of the penstock or the pipeline serves as a final setting basin, provides submergence of penstocks inlet and combination of trash bag and overflow arrangements. Silt basin or forebay tanks. The water drawn from the river and fed to the ground occurs suspension of particles of solid matter. This solid matter is composed of hard abrasive materials such as sand that cause extensive damage and wear to the turbine handles.